Hello everyone. Through this video, we are going to discuss about some additional questions on transpose of a matrix. So here goes the first question. If capital A, the matrix given to us is capital A, its values are entries are -1, 1, 0. This is the first row. The second row is 0, -1, 1. Then the third row is 2, 3, 4. So this is the matrix given to us. Then verify that 3 by 2 A dash is equal to 3 by 2 A whole dash. So coming to the solution part, the question says that along with A we need to get A dash also, then only this verification can be performed. Here what is A? Let us write that first. A is equal to -1, 1, 0, then 0, -1, 1, then after 2, 3, 4. This is a matrix given to us, and so A dash is equal to so in this case the first row will become the first column, so I get the result as -1, 1, 0. The second row will become the second column, 0, -1, 1. The third row will become the third column, 2, 3, 4. So this is the result for A dash. Then after coming to the verification part, let us start with the LHS. So the LHS given here is what? 3 by 2 A dash. That means with 3 by 2, this is a scalar term, I'm going to multiply the value of A dash which we have already evaluated. -1, 0, 2, then 1, -1, 3, then 0, 1, 4. Let us check what result we get after multiplying this scalar quantity to each and every term, each and every entry of this matrix. We get this result: -3 by 2, 0, then after 3, then after 3 by 2, then -3 by 2, then 9 by 2, then after I get 0, then 3 by 2, then I get 6. So this is the result for LHS. So coming to the right hand side, on the right hand side I shall be getting the expression actually already given in the question. Coming to the right hand side now, I have to put here 3 by 2 A whole dash, and for this I have to get this result, what is written within the bracket, that I have to derive first. That means 3 by 2 into the matrix A. The matrix A is -1, 1, 0, then 0, -1, 1, then after 2, 3, 4. This is the result for A, and again its transpose I have to find out. Let us check what result we get after scalar multiplication of this matrix with 3 by 2. I get the result -3 by 2, means 3 by 2 will be getting multiplied to each and every element of this matrix. So -3 by 2, I get here 3 by 2, then after 0, then after here it is 0, then after -3 by 2 again, then 3 by 2, then after 3, then after 9 by 2, then after I get here 6. Again its transpose I need to find out. While finding out its transpose, let us check what result do we get. When we find out its transpose, the result comes as the first column will become the first row. That means -3 by 2, then here it is 0, then here it is 3. Then the second column will become the second row. That means I get here 3 by 2, then after -3 by 2, then after it is 9 by 2. I told what? The second column will become the second row, and that's what I got. Then the third column will become the third row. So 0, it is 3 by 2, then it is 6. So ultimately we received a result which gives us that LHS and RHS both are equal matrices. So the conclusion to be drawn here is LHS, we find that LHS, RHS both are having equal values. So ultimately we can write here LHS, hence LHS equals to RHS. Verified. Verified. So this is the answer of this question. So here goes the second question. This is the second question. This question is something theoretical. What is said here, show that every square matrix can be uniquely, unique means one and only, uniquely expressed as the sum of symmetric and skew symmetric matrices. If I consider any matrix as capital A, that has to be expressed as the sum of symmetric and skew symmetric matrices. So here goes the solution part. So in this case, if I consider that, let the square matrix be the square matrix be capital A, then there is a way of expressing this in terms of transpose also. If I write like this, A as 1 by 2 into twice of A, then there is a way of expressing A in terms of transpose of matrices. So for that, first of all, I have to write it in such a way that half into twice of A. If I remove this bracket, bracket if I remove, then this 2 and 2 will be getting cancelled, and what is left behind? Only A is left behind. Then again, if I try to break it up, it will give us result A plus A. Now I am going to put plus A dash, I mean transpose of A, and minus transpose of A here. Means in the way half A dash, sorry, A plus A dash, I should better remove it. This will be A plus A dash plus A minus A dash, means the new thing that I am putting here is A dash and minus A dash, which again if I notice A dash and minus A dash can be cancelled out. So after this I can arrange, I mean I can keep the things together in this way, means half of A plus A dash, plus is there in between, again half of A minus A dash. Now individually for proving that the sum of two matrices, actually the square matrix can be uniquely expressed as the sum of symmetric and skew symmetric matrices. That means individually I have to show that this is symmetric, this is skew symmetric. In what way can it be shown? Let us check. I consider here, let capital B is equal to A plus A dash. For symmetric properties, I have to get what? Transpose of any matrix B should be equal to the matrix B. This is the property of symmetric matrices. So I find out transpose on both the sides. So finding out transpose on both the sides, I get the result A plus A dash whole dash here. After that, B dash will be equal to, I can write here, B dash will be equal to A dash plus A dash whole dash. What property we are using here? I am using the property x plus y whole dash is equal to x dash plus y dash. This property is used here. Then after using this property, I get the result B dash is equal to A dash plus, again there is a property for transpose of matrices, that is what? A transpose whole transpose is equal to A. I mean transpose of A is always equal to the original matrix A. So I get back here the result A. Again we know that matrix addition is commutative. So I can interchange the positions on the right hand side. So I get here a plus a dash. So it means what? B dash is equal to this result. Again, already we got that B is also having the same result. That means after this we can write B dash is equal to B. That means it shows that this is a symmetric matrix. Hence B is equal to A plus A dash is symmetric. Again, if I multiply both the sides by half, half of B dash is equal to half of B. That means, therefore, half of B is equal to half of A plus A dash is also symmetric. That means scalar multiplication of any matrix means we know that when the result is K A whole dash is equal to K A dash. Yes or no? So if this property is followed, then ultimately it is very clear that this matrix is also symmetric matrix. Means if any matrix is multiplied by any scalar term, its symmetric properties are not getting vanished. That means the first part which we had to show that half of A plus A dash was symmetric, it is proved to be symmetric. Now coming to the later part, coming to the next matrix, the second part, actually in this expression 1 we got two parts. Here I got two parts. This part is already shown that this first part has already been shown that it is a symmetric part. The second part is yet to be shown as skew symmetric. So coming to this second part, let capital C is equal to A minus A dash. Now finding out transpose on both the sides, we already know one thing, that when two matrices are skew symmetric, then we should get the result as C dash is equal to minus C. So here we are trying to get that C dash is equal to A minus A dash whole dash. So after this, what do we get? C dash is equal to, by property of transpose, we shall get A dash minus A dash whole dash. So after this, what result do we get? C dash is equal to A dash minus A. I am using the concept x minus y whole dash is equal to x dash minus y dash, and along with that, this property I am using y dash whole dash is equal to, say, y, only y. Transpose of matrix is equal to the matrix itself. So after this, I can take minus sign common. So if I take out the minus sign on the right hand side, I get minus A dash. So this gives us the result C dash is equal to minus of C. Therefore, C is skew symmetric. Then after this, scalar multiplication is required. Scalar multiplication means both the sides should be multiplied by half. Half of C dash is equal to minus half of C. Will be giving us a result. This implies C is equal to half of C is equal to half of A minus A dash is skew symmetric. Actually, the scalar multiplication of any matrix by any scalar term will not be changing the symmetric and skew symmetric properties of the matrix. This will remain as it is. So that's all. So from this, what is clear? It is clear that we already got this form, A is equal to half of A plus A dash plus half of A minus A dash. So ultimately we got a symmetric matrix. This is symmetric matrix plus or skew symmetric matrix. Hence proved or hence shown. So today in this video we discussed two questions. So in this video we discussed two questions. In my next video another two questions we are going to discuss. Thank you.